So in section 7, we're going to look at some three-variable systems of word problems. These are actually going to be very similar to the two-variable ones in how we set them up. It's just going to involve three equations with three variables for the solving part. In this first example, we're told the sum of three numbers is 6, the third number is the sum of the first and the second, and the first number is one more than the third number. Well, I'm going to start by defining my variables, and I'm going to say x equals the first number, and y equals the second number, and z equals the third number. The sum of my three numbers is 6, so my first equation is just x plus y plus z equals 6. The third number is the sum of the first and second numbers, so that third number, z, equals the sum of the first and second. And finally, we're told that the first number is one more than the third number. So the first number, x, equals one more than the third number is z, one more than that would be plus 1. So x equals z plus 1. So I didn't tell you in the directions how we're going to solve this. We could use elimination or substitution. What I think I want to do here, since I already have x equals and also have z equals, I might as well use substitution on this. I'm going to start by taking that x equals z plus 1, and I'm going to plug it into the x in my second equation. I'm also going to plug it in to the x in my first equation. When you plug into the first equation, you're going to get z plus 1 plus y plus z equals 6. And when you plug into the second equation, you're going to get z equals z plus 1 plus y. Cleaning up that first equation, we have y plus 2z plus 1 equals 6, minus 1, y plus 2z equals 5. In the second equation, well, I'm going to subtract z from both sides. And actually, that's kind of interesting. The z is completely canceled there. 0 equals 1 plus y. This is just a one-variable equation. I can just solve this for y and have my first variable. Y equals negative 1. Now I'm going to plug that into my two-variable equation down here with my y and z. So plugging into that, I get negative 1 plus 2z equals 5. 2z equals 6. Z equals 3. All I have left to find is the x, so x equals my z plus 1 by that bottom equation. X equals 3 plus 1, x equals 4. So x equals 4, y equals negative 1, z equals 3. I don't really want to give this answer as an ordered triple, though. Since it was a word problem, I do want to answer in words. I was just looking for three numbers here, so I'm going to answer by saying the numbers are 4, negative 1, and 3. And actually, I should probably be a little bit more specific. I should probably say the first number is 4. The second number is negative 1. And the third number is 3.